Nowadays, finding the eligible customers for loans from the pool of applicants is one of the major problems faced by banks and other financial institutions. Mainly, banks and other financial institutions need a customer who can repay the loan amount. To solve this problem, we are trying to build a prediction model using Bayesian logistic regression using the previous data so that it can predict whether a customer is eligible for a loan or not. The dataset was taken from Kaggle, which contains 606 observations and 13 variables. The top leftmost table shows the name of the attributes in the dataset, their types, and the number of levels. Here we can see most of the variables are nominal and the rest are integers. Loan ID, application income, co-application income, loan amount, and the loan amount term are integers, whereas gender, married, self-employed, education, and credit history are nominal variables with 2 levels. Number of dependents and property area are the other 2 nominal variables with levels 4 and 3 respectively. We can infer the following from the summary statistics of 3 integer variables: loan amount term, and total income. While considering the loan amount, mean of the loan amount is $146,000. The maximum and minimum amount is $700,000 and $9,000 respectively. Only about 25% of the total applicants require a loan amount that is more than $165,000. Similarly, while considering loan amount term, the shortest duration for which the loan applied is 1 year and the longest being 40 years. 50% of the applicants applied for the loan with a term less than 30 years. The next factor taken into consideration is the total income of the family. 75% of the loan applicant has total income greater than $4,000. Let's now discuss about the nominal variables. The frequency table of nominal variables are shown on the right hand side. We can see that more loans are approved for males. The number of approved loans is less than twice the values of rejected loans in case of females. But in case of males, the number of approved loan requests is almost 2.5 times the rejected loans. Similarly, for married applicants, the number of approved loan requests is more than 2.5 times the rejected loan requests. But the same for unmarried applicants is less than 2. Considering the case of education, most of the applicants are graduates. The number of approved applications for graduate is 260 and rejected applications is 103. Whereas for non-graduate, number of applicants is 56, which is less than twice the number of rejected applications, 34. We predict that the next variable should play a vital role in the decision making because the most of the applications with no credit history is rejected by the bank. Only 4 out of 65 applications with no credit history is approved. But in case of applicants with clear history, the number of applications approved is 313, is almost 4 times the number of rejected applications, 76. In case of self-employment, number of rejected applications is almost half of the number of applicants approved in both the cases. The ratio of rejected loan to approved loan is almost the same as the case of urban and semi-urban property areas. In rural area, only 79 out of 125 applications are approved. For the correlation metrics, we can see there is no significant relation between each independent variables. Hence, there won't be any multicollinearity issues here. But relatively a larger correlation value of 0.629 is obtained for total income and loan amount, which cannot be considered as significant. The scatter plot of integer variables against the loan outcome is shown in the top section. The first one shows the distribution of total income. From the applicants in lower income range, the approval rate is almost the same. But for the applicants with high income, the approval rate is very high. Especially above $40,000, the rejection is 0. Next, for loan amount, the approval rate is almost similar for lower loan amount. But as the loan amount increases, the approval rate is very high. In case of loan amount term, the loan amount status is pretty much the same. From the summary statistics of the integer variables, we can see that mean values are lying far from maximum values. So we change for the outliers in the attribute by plotting the box plot. From the below 3 box plot, we can see that outliers are present for loan amount, total income, and loan amount term, which may need to be considered while building a model. Here we consider a target variable as loan status, which follows a binary classification. After setting the model, we created the MCMC chains for different initial settings and performed MCMC diagnostics. By setting the initial values of adaptive steps as 1000, burn-in steps as 3000, number of chains as 3, thinning steps as 30, and saved steps as 5000, we obtained good chains for all parameters. Here, considered MCMC diagnostics graph for the beta 5 for our reference. From the trace plot, we can observe that almost all the chains are converged in the same region. We have given a higher value for burn-in steps, so all the chains are mixed well and we cannot find any isolated chains in the plot. Even looking at the density plot, we can find that all chains is overlapping with the HDA limit, which represents good representativeness of the chains for the distribution. We also have made sure that the shrink factor value lies well below 1.2, which too signifies the good representativeness of the distribution. From the parameter distribution, we checked for the significance of each predictors. The mode value of gender is minus 2.54. Even though the 95% HTA contains 0, we cannot neglect gender as 0 lies towards the right and the HTA with 92.5% of values rise to the left of 0. The mode value of beta parameter of married is 6.66. We will be considering this parameter as 96% of HTA interval, which lies to the right of 0. We can consider the education as an insignificant parameter since 0 lies in the center of 95% interval. The mode value of beta parameter of self-employment is 7.19, and we are not neglecting this parameter as 0 lies towards the left boundary of the HTA with 95% of values lies to the right of 0. The beta parameter distribution of loan amount and loan amount term suggests that they are significant in predicting the loan outcomes, as almost 95% of values of interval lies towards the left of 0. As we have predicted in the descriptive analysis of the data, credit history is a very important significant parameter in the loan outcome predictor with a beta value of 48.1. 95% HTA interval does not contain 0 in this case. Property area and total income can be considered as less insignificant parameters in case of loan output prediction, as 0 lies in 35% region of the HDI. From the figure, our built model can predict the loan status value at an accuracy of 60% and the fraction of relative instances among the retrieved instances precision is 41%. The fraction and the total amount of relevant instances that were actually retrieved, that is recall, is 50% and F-score is 45%. But we are receiving certain negative values for predicting probabilities, which needs to be rectified. A confusion matrix has been created for predicting test dataset. We used our model to predict 152 observations. There are 25 true negative and false negative values. There are 36 false positive and 66 true positive values in our predicted data. As mentioned in the parameter estimation, considered 6 predictors as significant parameters: gender, married, self-employed, loan amount term, and credit history. Since 0 is not lying at the exact middle of the graph, instead it is 30% or more farther from the boundaries. So as of now, we haven't excluded property area and total income from our study. Considered it as partially significant for our study, but we considered education as insignificant here. From the guess parameter graph shown earlier, 68% of the output is predicted by the model and the rest followed the guessing parameter. Obtained an MCMC diagnostic graph which can represent a good representativeness of the distribution. Still, we are looking to work on improving the accuracy of a model by modifying the model parameters like burn-in steps, thinning steps, etc. Also, we are trying with different prior information in order to obtain better output using a Bayesian analysis.